Hi, Kathy. All right, let's code, folks. Let's do this. I'm sure we'll have more folks. I know I saw in the last session, folks are hopping in and out, and there's a lot of great stuff happening. But like y'all are here on time, let's jump in. So you may have joined us in the last session. If so, some of this might be a little bit familiar, but just for anyone who's new, I'm Christina, and I'm a program manager at the Raspberry Pi Foundation.
And I'm Matt. I'm an executive director at the Raspberry Pi Foundation.
Yes, and we're excited to be here. We are going to be doing, this is our Light Up LEDs with Python and Raspberry Pi. And I'm really excited about this session. So Matt and I are part of a small but mighty team of 4. We make up Raspberry Pi Foundation North America. And we are part of the larger Raspberry Pi Foundation, which is a UK-based charity, specifically based in Cambridge, England. And super exciting to see so many of you joining us. I've seen folks share where they're from. Please, let us know. Say hi in the chat. Let us know your role and where you are connecting with us from. So if you're not familiar with the Raspberry Pi Foundation, the mission of the Raspberry Pi Foundation is to put the power of computing and digital making into hands of people all over the world. That looks like that's a big mission. So it looks like a lot of things. First and foremost, there's the Raspberry Pi computer, which is a $35 credit card sized computer. I've got one right here, and I can't see Matt, but I bet, yeah, he's showing his. Thanks, Matt. So that is one way we do this, making an affordable device that folks can use. We know that there are teachers all over the world, the country, that use the Raspberry Pi. You don't need one for this session. I'll explain how in a little bit, but you don't need one. But that is one way that we accomplish that mission. We also have programs like AstroPi, which is a really neat program where young people can write code and run it on the International Space Station, where we actually have 2 Raspberry Pis. Another example of that is professional development. Pi Academy is our free professional development for educators. We have some folks, Yolanda is one of our graduates, one of our Raspberry Pi certified educators, where folks come and learn about how to use the Raspberry Pi in physical computing. So if you've graduated from Pi Academy, please let us know. We'd love to. We know we have a lot of graduates, so we want to make sure that we're connecting with you. And so this is what we'll be doing today. Just wanted to do a quick introduction. And we're going to be doing a coding activity where we're going to be using Trinket and our Raspberry Pi SenseHat emulator. And we're gonna be doing a random sparkles activity. Get those LED lights shining. And then we'll take questions. We'll also be taking questions throughout. I asked Matt to join me this evening because those of you, if you've ever done like a presentation like this, it's hard to make sure you've got the presentation up and manage the chat. And I wanna make sure we get all of your questions and input. So feel free to put in questions throughout the session, and Matt will make sure to flag those for me. And then we'll talk about some next steps. Like if this was exciting for you, if you enjoyed this resource, we'll talk about some other resources you can check out and some other tools that you can bring to your classroom for computer science activities. So let's start with our coding activity. So we're going to be doing the random sparkles activity. This is one of my absolute favorite activities that we do at conferences with kids and adults to get to help folks, especially folks who are coding for the first time. So I wanted to give you this an idea of what the setup traditionally looks like. And here, see here, we have our Raspberry Pi set up with a monitor, mouse, and keyboard. I think you can see my mouse. Can you see my mouse, Matt?
Yes, yep.
Okay, great. So you see we've got the Raspberry Pi right there at the bottom with the SenseHat on top. And then we've got our random sparkles card, activity card. And we do this session, and like I said, I love it because you'll see that excitement. That photo in the bottom right is one of my favorite photos. This young lady had just gotten her code to work. We've been debugging it together, and that was the moment. I knew it was about to happen. And I managed to capture it where she had gotten her SenseHat to sparkle. So I'm excited to do this project with you all today and show you how, if you have Raspberry Pis, if you have SenseHats and you've been trying to figure out what to do with those, this is an activity you can do. If you don't have them, no problem. I'm going to show you a way that we've modified this experience so that you can do it virtually with your kiddos. So the Sense Hat, if you're not familiar with it, and if you are, please put in the chat. Let me know, like, do you have Raspberry Pis at your school? Do you have Sense Hats? If you're not familiar with the Sense Hat is a really neat attachment. I've got mine right here. So Matt, I think, had his, excuse me, we're gonna go back one second. Matt had his Raspberry Pi. So mine actually has the Sense Hat on top of it. So I'll hold that up there. I feel like an influencer with my hand behind me.
Yeah.
So this is an attachment that goes on the Raspberry Pi. And you'll see here, there's the Sense Hat. It's exactly what it says. It's a sensor. It senses the world around it. We'll be specifically engaging with the 8x8 LED matrix. But there's a temperature, humidity sensor, pressure. There's a mini joystick, so you can like actually code games on it and like press the button. There's a gyroscope, an accelerometer. So lots of really neat ways that you can engage and code. I see folks using this in the classroom, from using, for the example, the temperature, humidity sensor in like a greenhouse with students to collect data. We also see this used in research. So it's a really awesome and fun and affordable tool to bring to the classroom. So, however, in a perfect world, I would have been able to send everyone a Sense Hat that they could have and use. But since I can't do that, we have modified this project where we're going to be using the Sense Hat emulator. So,
can I share something about the Sense Hat? The whole reason the Sense Hat exists is because we have the Raspberry Pis on the International Space Station, and we wanted to make sure young people had the opportunity to write code that runs in space. And so this Sense Hat was developed for that program so that young people could have sensor hardware on the ground that matched sensor hardware that was orbiting Earth. And then they could write code here on Earth, and as part of the AstroPi program, send that code up to the International Space Station. It's really cool.
Yeah, I remember learning about that. This was just created for that, which is such a neat thing. And it's always something that we're talking with kids of, like, they're like, wait, like up there? Like, it's actually up there. And to realize that and to have their code run is such a cool experience. So what we'll be doing is we're going to be running through that activity card you saw in that picture. And so I want to start by just giving you that link so you have it, rpf.io/sparkle PDF. Feel free to take this, use it. This is a resource for you. And so this is a condensed experience from our actual larger project, which I'll share about at the end of the session. So Matt has put the link in the chat, so you've got it there. So I'm going to go ahead and show you on my screen. This is a PDF, and it has sort of the instructions. So this is a neat way. So if you're in the classroom with students right now, you could print this out, have this at their desk. They can use it. If you are having a virtual classroom, this could be a resource that you link out for kids. So you'll see here, we're going to be going through this. We're going to start by making a single LED light up. Then we're going to be using code. Oops, sorry, my scroll is working. We're going to be using code to set it up for the computer to identify a random number and random color, and then make it sparkle. Now, we're going to be using Python. So as I'm going through this project, I'm going to assume that you may be new to Python or new to using the Sense Hat emulator. However, I'm curious, if you have used it before, please put that in the chat. I would love to know, and also just ask you about your experience. It's awesome if you have used it before. So one thing I want to identify here is, you'll see in this document, we have double click the icon on the desktop. That's the instructions that we have for when we use this as an in-person activity. So I just want to flag that for folks, and something to consider for when you set up how you're going to set up doing this random sparkles activities with your kiddos. So we've got our PDF. Next thing we do is we're going to start the coding. So we're going to be going to Trinket, and we're going to be using rpf.io/sparkle20. So this is a starter project. So it has some code already in it. So I encourage you to use that link, and feel free to take this link, use it with your students, with your kids. So you have the emulator already in there and some starter code. So thank you, Matt, for putting that into the chat. And let's go ahead over there. All right. So when you click on the link, you're probably seeing something like this, or maybe like this. Oh, yeah. So mine's a little bit zoomed in, which is why it looks a little bit different. But you'll see there's two views of the sense hat, which we see here over on the right. I can change that view by clicking here in the bottom right. I'm going to change it to the green version, which looks like the sense hat like I have in front of me.
The gray one is what it looks. That's what the equipment looks like up on the space station.
Right. Yeah, exactly. And this is Trinket. This is an all-in-one coding environment that's great for education. And this is what I'm going to be using today. So we are using the Sense Hat emulator in Trinket, and we're going to be coding with Python. So like I mentioned, if you're just joining, let us know if you've used Python before or used the Sense Hat emulator. I'm going to be going through the session as if maybe you haven't coded with Python or haven't coded with the Sense Hat emulator. So with just a little quick introduction to Trinket, I'm going to be coding here in the left. We're going to see that code come alive here on the right. If you want to change any settings, you can adjust these windows. Feel free to do that. Also here on the left is a menu if you want to change the size of your code. Right here at the bottom, or if you want to like go full screen. Let me know if I think mine looks good on your end, but let me know if you need me to change the size of my code, you need me to zoom in or anything. I want to make sure you can see. And I think if that's, and also I'm not signed in to Trinket. Similar to like Scratch, you can just jump right in and code. You don't have to have a login. You also don't have to have a login to like save your project. If you don't want to create a login in Trinket this evening, but you want to save the project, you can click on this arrow and get a link and just hold on to that link and you could be able to return to the project. And that's what I did when I made this specific starter project for you all. I think that's it with Trinket. So let's actually code an LED. I'm excited. Wednesday night LED time. Let's do it. So I have these first 4 lines of code in here, and we do this with our session. I do this with kids when I do this project because I want them to jump right into using to coding and seeing the immediate sort of response to their code. And I found that this is a really good practice because then I can reference those lines later on. And you'll see how I do that as I walk through this project. So the first thing we are going to do is we are going to run this, or excuse me, I'm gonna pull up my notes. We're gonna go ahead and locate one of the pixels. So to do that, we're gonna have to create a variable. So first we're gonna do is create a variable called x equals, and we're going to set it equal to a number between 0 and 7. So I mentioned earlier this LED matrix, all these dots here, this is an 8x8 grid with points like a coordinate plane from 0 to 7. So I'm actually going to do 0, and then we're going to create a y variable. And I'm going to make that one 0 too. And I like doing that because it just actually helps me sort of know where the 0, 0 location is. Because sometimes depending on if I have my Raspberry Pi, it may be in a different direction. Right. I can't remember. Right. So that's helpful to do. Then we are now going to, we've identified our location. I'm going to do 0, 0. Now we are going to create 3 more variables for the color of our LED. So R, G, I'll give you a second to guess what these are. R, G, and B. Someone going to put it in the chat. Red, green, and blue. Mm-hmm. So with this variable, we can use a number from 0 to 255. So I want to make this first LED green. So for R, I'm going to put 0. I'm not going to put in any amount of red. Then for G, for green, I'm going to put in full amount of green. I'm going to put in 255. Then for blue, I'm going to put in 0. So we've got our numbers in there. And the last thing we need to do is we're going to use the set pixel function to tie it all up. I like how I described this. So we're tying it up with a ribbon, bringing all of our code together, telling our computer to find this location and use this color. So that line here, set underscore pixel X, Y, R, G, and B. All right. So let's run it. I'm always like fingers crossed because we all know like if you've coded before, it doesn't always work and that's okay. We'll figure out why if it doesn't. So let's see. Running my program. Oh, yes. All right. So
There's a little bit of lag on, at least on my side. There we go. We just saw it now. I don't know if it's just me, but there is some lag between you and the screen sharing.
Oh, okay. Thank you so much, Matt. Okay. I'll try and it's hard to hold that excitement in though. Right. So for those of you at home, like I hope it's working. And if not, like feel free to put your questions. We can definitely help to debug with you. Check the code that I have up here. But we identified our LED, we identified our colors. So at this point, if you're doing this project with students, I always encourage kids to change up the numbers. Really see that connection between what they're seeing on the LED matrix and what their code is doing. So let's go ahead, we'll change this to 5, and let's do another color. We'll do 150. Take this out, just 4. Just do some random numbers. Let's see what we get. Okay, so now let's run it. We should get a new. Okay, all right. So it should show it for you all in a second. Yep. We got a new LED. And we've got a different color. So we've gotten our light. And this is like sometimes this is enough. Like depending on the time you have, what you're working on with students, sometimes this is enough to start with, and kids can play around with these variables, and you can talk more about the code, like the first 4 lines of code, and or just how they're coding like the variables in there. So what we're going to do now is, this project is called Random Sparkle. So let's bring in the random. What we're going to be doing is we're now going to use code to tell the computer to pick random numbers. Before I was picking the numbers, right? And we're going to have the computer choose by using the random module. So that's what this line is here. Line 4, we're using the random module and using the random integer function. So for X, I'm going to change this from, instead of being 5, I'm going to tell the computer it can pick a random number between 0 and 7. So randint 0, 7. And so we can do that now for all of these lines. For me, lines 7 through 11. And you can also, undo that. You can also copy and paste, which is great. You can highlight and copy and paste. Maybe if you don't want your students to do that, you want them to type out the code, you can not tell them that. But yeah, so we're going to add this in. My mouse is being a little funny, so I'm actually going to type it in. All right. So I'm going to put in 0 to 7 here, and then do the same thing for red, green, and blue. And so now I'm telling my computer it can pick any number for the location and any number for the color. Great. To this last one. Again, fingers crossed, this is going to work. Okay, looks good from my end. And always let me know if you see any bugs in my code, please. We're a community helping each other out. All right, so, okay. All right, I'm seeing a random location. I didn't pick that in color. I'm gonna click it a couple more times. And when I do this with kids, I start to see them, they get really excited and they start to click and click and click. And they're gonna start seeing a bunch of different colors and lights showing up, which is a lot of fun. And this is when I tell them, okay, now let's make it sparkle. So to make it sparkle, we're gonna add in a loop. So if you're new to Python, to do a loop, we're gonna use a line of code. We're gonna put in while true. And I'm gonna add that below line 5. So below those import lines that we see 4 and 5, but above the variables. So we're gonna put in while true. And note that the while is a lowercase w, but the true is a capital. And Python is case sensitive. That's an important thing to remember if you're new to using Python. If you are new, please let us know. I'm super excited that you're here. If this is your first time coding in Python, that's awesome. It's really awesome. All right, so I've got while true, but I have a couple of things I need to do to make sure this code works. First, we won't need to indent. So when you're using a loop in Python, we want to indent the code that comes under there. So you can either just go through line by line and do tab, or in Trinket I can highlight, and I'm going to do tab. Now, what is happening right here is I am telling the computer, hey, computer, I want you to run this program. I want you to pick me a random location, a random color. And what I want to do is I want to tell the computer how often to do this. So that's where line 5, that code in line 5 comes in. I'm going to use the time module and use the sleep function. So I'm going to add in a line right under 15. So new line, line 16, also indented. And I'm going to put in sleep. And for the amount of time, I'm going to go ahead and do 1/10 of a second. Oops. Let's see how that looks. Fingers crossed. All right. Okay. So on my end, I'm starting to see it. You're going to see it soon in a second. The computer is running this program, and we are getting random sparkles happening right now. Random colors, random locations. I'm going to make it a little faster because that's always fun too. And the question I'll ask kids, well, okay, we've got our random sparkles. How can we make this faster? And they'll be like, oh, okay, I'll change the number. And maybe might have to talk to them about decimals and fractions depending on their age, what grade they're in. But we'll go ahead and add a 0 and make this 1/100th of a second now. And make this even faster. So this is an activity, as you can imagine, like on a Raspberry Pi, like having these LEDs light up. There's no experience like it. It's one of my favorite activities to do with kids. But this activity, as Matt and I have modified, is one way that we hope that you guys can bring this experience to your students, having them code in Python, seeing how they can use Python to control the LED matrix. So something that you can also do is, like, we see all of these numbers in here, encouraging kids to change up these numbers, seeing what they can do, either having maybe one section of the LED matrix or one, like a type of color gradient, maybe just purples and blues. A lot of really fun creativity can come out in this project. So I want to pause for questions. Is anyone having trouble with your code? Like, do you need any support? And this is the time to ask. I love debugging. So please don't hesitate to let us know if you need some support there.
And while we're waiting for questions, I'll say that this emulator doesn't just do the LED pixels; it also does pitch, roll, yaw, the sort of orientation aspect of it. You have those little scroll bars at the top, those little slider bars for temperature, pressure, and humidity. So if you have young people who want to explore using those sensors and they don't have access to hardware, at least they can emulate it. And then you get the hardware down the line. The code just works on the hardware after that. This is just a fun way to simulate having physical hardware.
Yeah, definitely. Thanks for mentioning that, Matt. I think that's such a really good point. Exactly.
And you can drag and move the orientation of that Raspberry Pi. So you can have code that reacts to shaking it or tilting it, and you can experiment with it in emulation. It's really fun.
Mm-hmm. Yeah, it's a great way too. Like, if you have Raspberry Pis or Sensat, if you want to have kids start with this and then having them get comfortable before they move into using the actual Raspberry Pi. So I'm going to wrap up if there's no questions there around using Trinket, and I want to move into some extra resources that we have that you all can use. And just to summarize what we just did, we looked at how to control the SenseHat LED matrix and choose random positions and display random colors, and then use Python to communicate with the SenseHat. So that's what that activity would bring to your CS experience in your classroom. So we have a couple of really awesome additional resources that I just want to share with you all that you can bring back to your schools, to your classroom. First is Digital Making at Home. This is a program that Matt and I both work on. This is a weekly live stream. So every Wednesday, we do some live coding. We talk with really cool folks. This is us coding a project with Jordan. We're making a really fun game in Scratch. This morning, we spoke with Randy, who is a PhD student. Randy Williams is a PhD student at MIT, and talked about machine learning. A couple weeks ago, it was a really good show. Check it out. If you go to rpf.io/home, all of our past episodes are on there.
Yeah,
and today
that one's at the top right now. The machine learning one, really cool. It really uses a teachable machine from Google, and it combines it with Scratch. Really cool.
Yeah. And we have tons of themes, and also we've been recently bringing in some just really amazing folks who talk about their careers. And so Randy was so awesome just talking about her journey to computer science and engineering and how she ended up working with machine learning at MIT, which I love hearing these stories. And we specifically ask them questions to help young people learn about how they could explore these types of careers. So definitely check those out. They're really awesome. And you can always connect with us too. There's a way you can go to the website and feel free to email us if you have information or want to chat more about digital making at home. Then we have our projects. So the Random Sparkles project, that PDF, at the end of the PDF, it links you to the actual larger Random Sparkles project. That's a condensed version that we have for conferences, for sessions, kind of to get that initial spark, to get folks excited about coding. We also have over 200 other projects, from Raspberry Pi, Sensat, also Scratch, HTML, CSS, Python, and Microbit. You can definitely encourage you to check them out. These are free. These are available for you all to use. And it's
translated
too?
Yes,
in over, I think, 28 languages.
Yeah.
Incredible. So these are I think something that I'm the most proud to share. Having been a former educator, I know it's super hard to find resources. I remember my first year, I was like, what is happening? Like, why do I feel like I'm reinventing the wheel? Like, this shouldn't be the case. So these are here and free for you all to use. So that's at rpf.io/projects. And that link is in the chat. Then we have one more. We have our online courses. So these are free courses that are available right now. You can go to rpf.io/trainonline. And we have courses there from how to start a code club to programming 101 to the ethics of computer science and these are all made for teachers, for you to learn how to bring these topics into your classroom. So for example, there's one here we see Scratch to Python. And this is a really great, I love this course because this is a question I get a lot from folks. Like, how do I move from Scratch to getting my kids on, to doing a text-based language? And this is a great course. And what's neat is that this course is facilitated live by our team. So all these smiley folks over here on the right, they're on the course. And they're answering your question. So they're here to support you. I'm sometimes on the courses. So I'd love to connect again if you join any of those courses. And one other thing we have, I didn't have a slide, but I want to mention it because Yolanda gave it a shout out in our last session, is we have an event called Coolest Projects, which is a showcase for young people to share what they've created with code. So you can go to coolestprojects.org. This is an event that in the past we've hosted in person. This summer we did it virtually. It was incredible. We had kids from all over the world creating videos and sending in projects that they've made with code and technology, from robots to websites. And we're definitely bringing it back in 2021, so stay tuned for more information. You can check that out. I'm saying thanks, Yolanda, for the shout out in the chat. I appreciate it. So I want to open it up for questions, either about the project we just did, Random Sparkles, the emulator, Raspberry Pi, any of the resources. Matt and I are here to help you all. Our passion is making sure that you all have the support you need to bring computer science experiences to your kids. So while you all are typing in the chat, I think I've addressed all the questions there. One thing someone asked in the last session was, how can you follow along for more information? If you have a Twitter, you can follow Raspberry Pi on Twitter. And Matt will put that into the link. That's where our team puts out all the updates on either new projects, new courses, resources. If you want to follow me or Matt, I'm Foust Berry Pie. Matt Richardson, he's got more original. Well, I don't know. It depends on what you think in regards to original. But we post about the activities that we're doing with coding in our community, as well as personal stuff. Mine will be full of puppies pretty soon. Just learned we're picking up our puppy on Saturday. I'm so excited. I'm very excited. So I don't see any questions. I'm just going to wait a couple more minutes. And I just have to say, I'm crushing time. Crushing.
Yeah.
I've got a timer up here in front of me to make sure I don't go over. But yeah, thank you, Kathy, Shannon. Thank you, Megan, for coming to this session. I know you came to the first one. We love connecting with folks. And actually, Matt, could you put my email in? My email is Christina@raspberrypi.org. My role is specifically to help create spaces for kids to code. That looks like clubs. That looks like coolest projects. So feel free to email me if you have any questions. I know I'm not like, I always struggle to like put questions in like the chat or like live. So, oh my gosh, Kathy. Oh, Kathy, I'm getting an Australian Shepherd too. Kathy, we need to talk. Email me, Kathy. No, I need to know about the. I am getting an Australian Shepherd on Saturday. I just got chills. I'm really excited. It's 8 weeks, a girl. Don't have a name yet. We're gonna let her pick her name. So really excited about that. Thank you for sharing that, Kathy. Oh yeah, thank you all so much. We don't have any questions. Oh, we got questions here. Any ideas how to use Raspberry Pi devices safely in this current COVID environment? Simulator is awesome. If I can come up with any, can you? What is FTF? I'm assuming
face to face.
Oh, face to face. Gotcha. That's a good question, Matt. Do you have suggestions on that?
You know, I off the top of my head, I don't. I'm a little reluctant to give advice if I don't have the research to back it up. You know.
Yeah.
You know, if there is a way that kids who get kits or using kits are using them, are the sole people using them for that period of time for that lesson, and they're not used, you know, I don't know how long it takes to make sure. It's a tough question, and I'm sorry I don't have an answer off the top of my head for that.
Yeah, it's definitely a good question. I think folks, I know, like, have used, like, had kids only use like the same SD card,
Right.
but they also now have assigned kids the same Raspberry Pis, because you want to be mindful. I think it's similar to how anyone might be approaching just in general devices. If you have, instead of kids having, maybe they don't have a one-to-one device, you might have a set of Chromebooks. Probably a similar like process to that, but it's tough. I think Yolanda's saying that she gives the same Raspberry Pi in a pencil box, so it's always assigned to them, and all items are stored in that plastic pencil box. So it may be helpful to connect with Yolanda. Thank you so much, Yolanda, for suggesting that. It's definitely, we're tough times we're in, and I know teachers, you all are incredible. So my email is in there, Christina@raspberrypi.org. Happy to connect with you all and brainstorm ideas and hear what you're doing. We always love sharing with our community. We have a magazine, or like a published, called Hello World, and that is a magazine for educators that talks about, and has recently talked about, how folks are approaching computer science currently, and especially if you're not able to be in a classroom, or if you are able to be in a classroom. So I encourage you to check out Hello World. And yeah, I'm excited to hear, Autumn, that you're glad that we have the simulators. Let us know. Yeah, please, like, I would, once you're using those, feel free to send me an email. I'd love to hear how it goes. So
I think the main session might be happening, right?
I think it is. Well, we're done at 6:20, so we're right on time.
Sorry.
Yeah, don't worry, Matt. I got it.
Right.
Awesome. Thank you for keeping time. All right, folks. Well, thank you all so much for joining. Really appreciate, loved connecting with you all. And hopefully we get to connect with you soon. We always love to hear about your Raspberry Pi adventures and coding adventures. So good luck, stay safe, and bye.
Bye, thanks.